In this video, we are going to be looking at the 5 questions on applications of differentiation. Let us now look at question 1. Given the equation of this function, where p and q are unknown integers, question says that the only values of x for which y is a decreasing function are those between x between 3 to 7. So this means the question is telling us that the graph is only decreasing between these values. Now we know that when a function is decreasing, it means that the dy dx would be less than 0. So they're basically telling us that dy dx is less than 0 only when x is between 3 to 7. Now normally the question will tell us that it's a decreasing function and ask us to find the range of values of x. So in this case, why are they giving us the values of x? Because if you look at your equation for y, there are unknowns p and q. So our dy dx would have unknowns as well. So instead of asking you to find the range of values of x, this question gives you the range of values of x. So you will need to work backwards to find the unknowns in dy dx. So the concept this question is testing is still dy dx less than 0. But the approach to this question is to work backwards from the answer for the inequality to get the original inequality. Now let us look at what dy dx looks like. Now this is a polynomial expression, so you should be able to differentiate it, bring the power down, power decrease by 1. Similarly for px squared, bring the power down. Qx, when you differentiate, you will end up with q. 10, when you differentiate, you will get 0. So you'll notice that dy dx is actually a quadratic expression. Now, if I were to solve this quadratic expression, if I were to solve this quadratic inequality where this is less than 0, let's think about what would the steps be. First, I will need to factorize this. Of course, now I can't do it because p and q are unknowns. But after I factorized it, I will sketch a graph, a quadratic graph. Coefficient of x squared is positive, so I have my happy face graph. From the factorized form, I would be able to tell what are the two x-intercepts. And because the question wants the range of values for which it's less than 0, we will be looking at this region. Then from there, we will be able to write down the range of values of x. So it will be between this value to this value. Now, since this question is the reverse, we will basically need to work backwards from here to get the original inequality. Okay, so let us take a look at how we can do this. Now, since the question tells us that x is between 3 to 7, that means to say these values on the graph must have been 3 and 7. Now, if these values were 3 and 7, what would the factorized form have to look like? This must have been x minus 3, x minus 7 less than 0. Now, if I compare this with this form, you would notice that the coefficient of x squared is 3. However, here my coefficient of x squared is 1, which means in this factorized form, there must have been a 3 which has been factorized as well. Now, if I expand this, I will be able to get an inequality that I can then compare with the original inequality from the question. So can you see that this must have been the original inequality? Now I can compare it with the inequality in the question. So we know that dy dx must be 0. So if I compare this inequality with the inequality that we have just gotten, 2p equals to negative 30, therefore p must be negative 15. And q equals to 63. So I'm basically comparing the constant terms and the coefficient of x. So this is for question 1. Now let us go on to question 2. For question 2, question tells us that y is defined for x more than 3 over 2. So they are basically telling us the condition for the function y. And then they have given us the function dy dx. So this question didn't tell us what y is, but they have given us dy dx. for part 1, we are supposed to explain whether y is an increasing or decreasing function. Now, in order to determine whether y is increasing or decreasing, we need to look at the gradient function of y. If the gradient function is more than 0, we know that y is increasing. If gradient function is less than 0, then we know that y is decreasing. Okay, so this question is testing on the concept of increasing or decreasing function. Now, since the question has already given us dy dx, that saves us the trouble of having to differentiate. So we can immediately start to figure out whether the dy dx given is more than 0 or less than 0. So this is the dy dx. So we're going to have to start with the given information where they tell us x is more than 3 over 2. So always start with the given information. If x is more than 3 over 2, if you look at our dy dx, the only place x appears is over here. So let us try to figure out whether this expression would be positive or negative. If x is more than 3 over 2, if I were to multiply 2 on both sides, 2x would be more than 3. If I were to subtract 3 on both sides, 2x minus 3 would be more than 0. So I'm basically trying to get this expression on the left-hand side of the inequality. So this 2x minus 3 is positive. So if I have a fraction where the denominator is positive and the numerator is 6, 6 is also a positive number. Therefore, 6 over 2x minus 3 will definitely be positive. Now, if I were to add a 5 on both sides of the inequality, I can see that my dy dx will be more than 5 and therefore more than 0. Since dy dx is more than 0, this must mean that y is an increasing function. So that is for part 1. Now let us take a look at how to do part 2. For part 2, question wants us to determine whether dy dx is an increasing or decreasing function, and we are supposed to look at the second derivative to do this. Now, just now we saw that to determine whether y is increasing or decreasing, we need to look at the gradient function of y. Now, to determine whether dy dx is increasing or decreasing, we need to look at the gradient function of dy dx. The gradient function of dy dx is the second derivative. So this means we need to figure out whether the second derivative is positive or negative. If the second derivative is positive, it tells us that dy dx is increasing, and if it's negative, it tells us that dy dx is decreasing. So for this part, we first need to differentiate our dy dx to get the second derivative. Let us differentiate 5. Differentiating 5 will give you 0. The next term in my dy dx is 6 over 2x minus 3. Now 6 is just a constant, so I do not need quotient rule for this question. So all I have to do is to rewrite this term as 6 times 2x minus 3 power negative 1. Now I can differentiate this term. I'm going to leave the coefficient as it is, bring the power down, and the power decreases by 1, and then differentiate 2x minus 3, so I get 2. So using chain rule, I brought down the power decreased by 1, and I differentiated the function inside the bracket and multiplied by this. So second derivative is negative 12 over 2x minus 3 squared. So remember, now we need to figure out whether this expression is positive or negative. Now for this expression, you can see that the denominator is a perfect square. 2x minus 3, the whole thing is squared. So I do not need to start off with this given information because I can already conclude that 2x minus 3 is more than or equals to 0 for all values of x. So this is a known mathematical fact. However, you will notice I didn't write a equal to 0 here. It's just strictly more than. Why isn't it equals to 0? Because the question already tells us that x is strictly more than 3 over 2. So this bracket square wouldn't even be equal to 0. It will definitely be more than 0. Next, if I take a negative number and I divide by a positive number, which is the 2x minus 3 squared, this will give me a negative value. Therefore, the second derivative is negative. This tells us that dy dx is a decreasing function.